Today we're going to start Chapter 3 by discussing Lesson 1. Chapter 3 is called Parallel and Perpendicular Lines, and in Lesson 1 we're going to take a look at classifying our lines. We're also going to take a look at classifying some angle pairs. Most of this should be a review for you from what you had in your 8th grade geometry unit, and even 7th grade as well. So we should be familiar with parallel lines. Parallel lines are coplanar lines that do not intersect. So even though we know our lines extend forever and ever in each direction, parallel lines will never intersect, but you'll notice that they have to be on the same plane. And these two arrows right here are showing me that my lines are parallel. And so in some way your lines have to be marked to know that they're parallel. We can't just assume that. If I were writing, there's actually a symbol that shorthands for the word parallel. And so if I were writing JK is parallel to LM, it would look like this. Line JK is parallel to line LM. And so these two little kind of railroad track, that's the symbol we used for parallel. Now, perpendicular lines are lines that intersect at 90-degree angles or at right angles. And so we know if I had two perpendicular lines here, in order for us to know that they're perpendicular, they have to be marked with the symbol, which is that little box. And if let's just say I call this line AB and line CD, there's a shorthand symbol for perpendicular as well. I would write that my line AB is perpendicular to line CD. So the upside down capital T is what shows perpendicular. I can also refer to lines as being skew. Skew lines are actually non-coplanar. They're non-coplanar and they also do not intersect. They do not intersect, but they are also not considered parallel. Because remember, parallel has to be on the same plane. So if you take a look at my drawing here of my cube, they're showing or highlighting this line here and this line here. We were looking at the edges of our cube. Those lines are non-coplanar, and they're never going to intersect, but yet they're not considered parallel, and so those would be skew. Also over here in this diagram, these lines, line L and line M, would also be considered skew. Now, I can also have planes that are parallel. Parallel planes are shown here with plane B and plane A can be parallel. They are not going to intersect. And so if I were writing that, it would just be that plane A is parallel to plane B. Down below in example A, they are asking us to identify some pairs of segments. And I'll tell you that there are more than one possible answer for these. So as I look at number 1 and it asks me for one pair of perpendicular segments, well, we know that our perpendicular has to be at the 90 degrees, and so we're kind of looking for that 90-degree symbol. I had chosen my segment of MR and RQ, so when I write that, MR is perpendicular to RQ. But there are other examples as well. We could have said NS and SP. How about a pair of skew segments? Well, we know that our skew segments are going to not intersect, but they are also going to be non-coplanar. If I'm looking at the segment NF up here at the top, could you think about what segment that would be skewed with NF? There are other few possibilities. LQ would be skewed, KP would be skewed, RQ would be skewed. And so there are many different types of answers. Initially, I had just chosen that NN and LQ would be skewed. Parallel. We know that when we're looking for parallel segments, we're looking for the arrows. So you can see here that this is showing me NS and MR as parallel, or even down below with the single arrows here, SP, RQ. Any of those possibilities would work. NS is parallel to MR. Parallel planes, well, I was thinking my parallel planes, the top of my box to the bottom of my box would be two parallel planes, and those are the ones that I had chosen. You could also use the sides as well. Remember when you name the plane, technically I only need 3 points, so I could call it the plane KLM, and it really means the whole thing. You could say KLM as well. Parallel to plane PQR. And again, there are other possibilities for these questions. At the top of page 2, we're going to start talking about some angle pairs. And the first term that they introduce to us is the word transversal. Well, by definition, it says a transversal is a line that intersects two coplanar lines. What does that mean? Well, if I had two coplanar lines and my transversal is the line that intersects both of those, so it would cut through here would be my transversal. When we do that, you see that when the transversal cuts, I actually have all kinds of angles that are formed, and the two lines in the transversal actually form 8 angles, which can be classified into different types of angle pairs. As you look down below, here my transversal would be transversal T, this angle up and down, cutting lines Q and R, and have different angles formed. They're going to refer to some of those angles as being interior, meaning that they are on the inside of those two lines, and other angles being exterior, meaning that they are on the outside of those two lines. Okay, I can see interior would be 3, 4, 6, 7. Exterior would be 1, 2, 7, 8. And then also, we can refer to angles as being corresponding. When angles are corresponding, they are in the same relative position. So at the intersection point, in the same relative position, as I look at this diagram here, at this first intersection, angle 1 is in the top left, kind of that intersection. It would correspond with angle 5, also being in the top left. So angle 1 and angle 5 are corresponding angles. Likewise, angle 2 and angle 6. Also angle 4 and angle 8. Angle 3 and angle 7. Your angles can be considered alternate interior angles. By definition, they say that they are angles that are on the opposite sides of the transversal, but are on the inside of the two lines, which makes sense. We know that alternate means every other, so that's where they get the opposite sides. If I look down below and I want to find a pair of alternate interior angles, well, on the inside, 8 and 6 would be on the inside of my lines, but they're on opposite sides of my transversal. But I also have another pair as well. These angles here, 4 and 5, would also be alternate interior angles. My angles can be considered alternate exterior. Alternate exterior meaning they are on the opposite side of the transversal, but they are on the outside of the two lines. So looking here at my alternate exterior, well, if I picked angle 1, exterior, the one that would be alternate exterior on the opposite side would have to be angle 7. So angle 1 and angle 7 are alternate exterior. Likewise, the other pair we could have picked are angle 2 and angle 8. Same side interior angles sometimes are called consecutive interior, consecutive meaning side by side, right? So same side interior angles are just that. They are on the same side of the transversal, and they are on the inside of my two lines. And so we can see, well, same side inside, angle 3 and angle 5 will be same side interior. Or over here, angle 4 and angle 6, same side interior. Similarly, same side exterior may be called consecutive exterior. They are going to be on the same side of the transversal, but on the outside of the two lines. And so here, my angle 1 and my angle 8 would be same side exterior. Likewise, angle 2 and angle 7. So those are all the different types of angle pairs, and we're going to work on identifying some angle pairs. If you flip your paper over to example B, I've given you a diagram. We have two lines that are being cut by our transversal. So here's our transversal, which I'll call T. And I'm going to ask you to classify the relationship between each angle pair from our choices on page 2. And you can go ahead and abbreviate those. So as I look at angle 1 and angle 5, and I want to classify them, well, I can see that they are on the outside. They're going to have to be exterior. And I'm thinking, well, they're on opposite sides of my transversal. So I'm going to say they are alternate exterior angles. And when I abbreviate that, I do it like this. Alternate exterior angles. So you can shorten that out. So I'm going to give you a minute. I'd like you to think about how you would classify each angle pair, and then I'll go ahead and tell you what they should be. You may not be completely finished, but you can go ahead and compare what you have. We'll kind of talk through these a little bit. Letter B, angle 6 and angle 7. Well, I can see they're on the they're on the same side as my transversal. So I'm going to call them same side interior angles, and that's how I would abbreviate it. Angle 2 and angle 4. Sometimes kids get a little bit stuck on this one. Angle 2 here and angle 4. These ones are actually, one's on the inside, but one's on the outside. But they're both, these on the right-hand side of my lines, they are actually going to be corresponding angles. They have the same relative position at the intersection. To me, I can classify them as the upper right corner. 2 and 6 are going to be alternate interior angles. 8 and 5. 8 and 5 we know are on the outside. They're actually going to be same side, exterior. 5 and 7. Well, again, 5 and 7 are just across from my 2 and 4. They are going to be corresponding. 4 and 8. They are going to be alternate exterior. 2 and 3. Same side, interior. 3 and 7. Alternate interior. And then finally 2 and 5. 2. This one's actually kind of a trick question. 2 and 5, one's on the inside, one's on the outside. But they don't correspond. This one actually is not possible. There is an angle pair that we discussed where 2 and 5 would fit into. Sometimes they ask the questions in a little bit different way, in like an example C, where the diagrams are a little bit more complicated because I have more than just 3 lines. So example C asks us to identify the transversal connecting each angle pair, and then to classify them. So as I look at angle 1 and angle 3, angle 1 and angle 3, well, in each case my transversal is going to change, but the line that kind of cuts through and connects both of them is line H. That is my transversal in this case. So I'm going to say that line H is my transversal. And as I look at angle 1 and angle 3, I can kind of ignore this part of my diagram. I am only looking here at 1 and 3, and they are on the outside of my 2 lines. They are actually going to be alternate exterior. If I look at angle 5 and angle 6, angle 5 and angle 6 are being connected by this line right here. It's a little hard to read. It's supposed to be a K, so that is the transversal K that's connecting them. And if I look at angle 5 and angle 6, they're on the inside, and they're on the same side of the transversal. So they're going to be same side interior. Which transversal connects 2 and 6? Well, 2 and 6 is connected here by this line. Again, a little hard to read, but that's supposed to be a cursive L, so it's transversal L. 2 and 6, those are actually going to be corresponding. Angle 3 and angle 5, well, when I look at the line connecting them, 3 and 5, this line here as my transversal is transversal J. Now again, I'm kind of ignoring this part of my diagram, and 3 and 5 then would be considered on the outside. They are going to be alternate exterior. 2 and 8. Well, the line that connects 2 and 8, again, is this ignoring the top part of my diagram, 2 and 8 would be alternate interior. And lastly, 5 and 7, the line connecting angle 5 and angle 7 is line K as my transversal. They both, in my diagram, have the same relative position. They're just below the line. They're on the right side. They are going to be corresponding. Okay, you can also see the online videos supplied by our textbook. If you have more questions, please come in and see me.